All right, so number 4 was the one most missed question. And the key to most logistic function questions is remembering the formats. All right, and when we're talking about the differential equations format, we know that for logistic, it's a joint variation between the number, if we're talking about like an infectious disease, the number infected and the number remaining that can be infected. So if P is the number infected, then L minus P, the total load or the total capacity, minus the population is the ones remaining to be infected. All right, so when I look at this, what I need to do is I need to get these each to this form, which really means that I'm going to be factoring out a P and then whatever's on the P squared term. So if I look at choice A, all right, in choice A I'd have dP dt. I'm factoring out a 0.001p. All right, that's going to leave me with 0.2 divided by 0.001, which is 200, all right, minus p. Now, at this point, we're actually right at the perfect format. All right, so this would give us a problem where we have a carrying capacity of 200. All right, now when I look at these, it doesn't look like any other is going to give me that same result. So as I look through, this is actually the only choice that leaves a 200 in this spot. So we get choice A. Now, occasionally you will see this written in slightly different ways. Sometimes you'll see them write it this way, where it's dP dt equals kp and then 1 minus p over L. All right, that's another standard form for a logistic function. And again, it's really the same thing. It's just that k value is actually different on this one. All right, this was the one we looked at. This was the picture we had lice minus licked with the tick and the picture of the cow snout in our notes. But again, this is the differential equations format, and then we also had the actual function format. But carrying capacity of 200, so we're looking at A because that matches up with what the graph has, which is a load of 200. All right, I hope that helps. Thanks.